ELEC 323 project, which is done by Salim Al-Rashidi and Talal Al-Azmi. Our project is the Piezoelectric Footstep power generator. So to start with, a piezoelectric sensor is an important and interesting subject in the research field. These kind of sensors are used to detect heat, pressure, acceleration, force, or temperature and convert it to electricity. When it comes to how the piezoelectric sensors generate electricity, the piezoelectric effect come in handy. Piezoelectric effect is the ability of certain materials to generate electricity as a response of mechanical stress such as quartz, zinc oxide, and topaz. Also, the piezoelectric effect can be reversed, where it can accept electricity and produce mechanical stress. So in this report, we will discuss the schematic symbol and electronic model of the piezoelectric sensor, which is shown in the figure in front of you. So our project, which is the piezoelectric footstep power generator, is designed to convert the pressure coming from our footsteps to convert it to electric charge that we can store it as a source of power using piezoelectric sensor as the main component. This process is shown in the figure in front of you. And so the piezoelectric transducer is used in our project is the piezo disc, which its middle part is lead zirconate. It is a piezoelectric material. So the purpose of our project is to sense the force coming from our daily walking and convert it to electricity, which can be used in different ways, such as charging our phones while walking. So for the components, so this piezoelectric sense is made from lead zirconate, which has a high piezoelectric properties, and it's widely used. A PZT has a very high DC output impedance and can be modeled as a proportional voltage source and filter network. The voltage at the source is directly proportional to the applied force, pressure, or strain, and the output signal is then related to this mechanical force as if it had passed through the equivalent circuit. So as you see in the figure left to you, it shows the piezoelectric disc model and the circuit in front of you. In the middle figure, we can see the inductance Lm is due to the seismic mass and interior of the sensor itself. Ce is inversely proportional to the mechanical elasticity of the sensor. C0 represents the static capacitance of the transducer, resulting from an interior mass of infinite size. Ri is the insulation leakage resistance of the transducer element. So if the sensor is connected to a load resistance, this also acts in parallel with the insulation resistance, so both increasing the high pass cutoff frequency. So as you see in the table in front of you, it shows the impedance which is equal or less than 500 ohms, and the voltage also equal or less than 30 voltage peak to peak, and the material are BZT, the lead zirconate, and the strain sensitivity equal 5 voltage over micro. So I will leave you now with Talal to talk about the full wave bridge rectifier.
The full wave bridge rectifier is basically powers diodes that are connected together to convert AC voltage into blasting DC voltage for use in power supplies. A full wave bridge rectifier provides more stability and will provide a steady and smooth DC supply voltage every half cycle, and it has less ripple than the half wave rectifier. This type of single phase rectifier uses 4 individual rectifying diodes connected in a closed loop configuration to produce the desired output. The main advantage of this bridge circuit is that it doesn't require a special center tabbed transfer, thereby reducing its size and cost. The single secondary winding is connected to one side of the diode bridge network, and the load is to the other side is shown in front of you. And we have the peak reverse voltage is the 400 volt. The four diodes labeled D1 to D2 to D4 are arranged in series pairs with only two diodes conducting current during each half cycle. During the positive half cycle of the supply, diodes D1 and D2 conduct in series, while diodes D3 and D4 are reversed based and the current flows through the load. And the next and third component, we have the diodes. A diode is a device which allows current flow through only one direction. The current should always flow from the anode of the diode to cathode. The cathode terminal can be identified by using a gray bar or our type diode, which is 1N4004. The maximum current carrying capacity is 1 ampere, and it peaks up to 30 ampere. Hence, we can use this in circuits that are designed for less than 1 ampere. The reverse current is 5 microampere, which is negligible. The power consumption of this diode is 3 watt. The second diode is the light emitting diode, is a semiconductor light source that emits light when current flow through it. Electrons in the semiconductor combine with electron holes, releasing energy in the photons. And Salim will continue to the other components.
So for the other components, we have a switch which is used to turn the circuit on and off, and 1000 k ohms resistance is applied to the circuit to avoid huge currents that may result in component damage. Also, a capacitor is used in parallel so the current can go to it. Only the capacitor, the branch, which will charge the capacitor fully. When the capacitor is fully charged, then it will act like a battery, and it will discharge the power to the other part of the circuit. So, in conclusion, this project purpose was to serve electricity with using unconventional ways like the piezoelectric sensor and the piezoelectric sensor, which is the BZT or the piezoelectric disc, which has a strong piezoelectric properties. We used a full wave bridge rectifier to change the AC output to DC to prevent negative output. Then we had two diodes were used, the IN4007 to help the current to go in one direction, and an LED light to indicate the current flow. And other components were used to help the circuit, like resistance and capacitance and a switch. The circuit was tested on circuit to prove that it works. So the aims of this project is to have more knowledge on how piezoelectric sensor, to use our knowledge in this course in implementing helpful devices and also converting pressure coming from footstep into electrical current. And thank you so much.